It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about circular functions. Let us first know our 6 trigonometric functions. We have our sine theta, cosine theta, tangent theta, cosecant, cosecant theta, secant theta, and cotangent theta. So once we are going to look for the 6 trigonometric functions of the angles, we can look back on the triangles that we did when we had our unit circle. So looking back, we've got these angles here. Triangle. We have our 30, and then we have our 60. So opposite to 30 degrees in a unit circle, we have that as 1/2. And then opposite to 60 degrees, that is square root of 3/2. While opposite 90 is a 1. And then we also have to consider that we've got our 45 degrees triangle. We have that as square root of 2/2. Square root of 2/2 here. And we have 1 here. And then, these are the things that we are considering here in looking for the different values of our trigonometric functions in a unit circle. Now, since this is in a unit circle, once we say sine theta, this is always equal to opposite over hypotenuse. Opposite, if you are going to look back on the location of the angle in a Cartesian plane or in a unit circle, this will always be connected to the positive x-axis because we're considering that one as in standard position. And we are trying to form a right triangle here, in which opposite to that angle is always going to be the value of y in the coordinate, and opposite or adjacent side to that angle will always be our x. And the hypotenuse will always be a 1 if that is on a unit circle. So utilizing that one, once we say sine theta, this is opposite over hypotenuse. Opposite to the angle is y over hypotenuse is 1. So that means once we say sine theta, this will always be equal to a y in our unit circle. Going over with cosine theta. Cosine theta is adjacent over hypotenuse. Adjacent side to that angle is our x over hypotenuse, which is 1. Our cosine theta will be equal to x in a unit circle. Next, we have tangent theta. Tangent theta is equal to opposite. So opposite of that angle is y over adjacent, which is an x. Next, we have the cosecant theta, which is an inverse of the sine theta. So since this is inverse of the sine theta, if sine theta is y, then cosecant theta will always be 1 over y. Secant theta, this will be an inverse of the cosine theta. If cosine theta is x, then secant theta will be 1 over x. Cotangent theta is an inverse of the tangent, so which means that if tangent is y over x, cotangent is x over y. So using those information, we now have our information for the different values in here. So once we have here sine 30 degrees, we are going to look at, if you notice, let's try to go back to our Cartesian plane here. If you notice, if this is the location of the angle in standard position, the one which is opposite to that one will always be our y. The one adjacent to that one will always be the x. So going back, using this triangle here, once we say sine 30 degrees, we have that as sine 30 degrees is equal to y, or the opposite of our 30 degrees. So that should be a 1/2. Now, it is better for you to do that one, or do this one, with the coordinates of the terminal side, or the coordinates of the intersection of the terminal side, and so with a unit circle, because in that way, you can really visualize that if we say 30 degrees, the coordinate of that one will always be gonna be 1/2. I mean square root of 3 over 2. And then 1/2. So if you are going to do sine 30 degrees, we have that as a y. Our y there is 1/2. And then our cosine theta, that will be the x there, which is square root of 3 over 2. Next, our tangent theta is only gonna be y over x. Tangent theta here, or tangent 30 degrees, that will be equal to our y, which is 1/2, over our x, which is square root of 3 over 2. Since this is fraction divided by fraction, we need to simplify that one. So we have 1/2 times our square root of 3, our reciprocal of the square root of 3 over 2, which is gonna be 2 over square root of 3. This time, we can cancel that one, so we have 1 here and 1. Simplifying that, this is 1 times 1, which is 1 over 1 times square root of 3, which is square root of 3. We are not yet done because we have a radical symbol at the bottom part, so we have to cancel that radical symbol out by rationalizing. We have that multiplied with square root of 3 over square root of 3. So this time we have now 1 times square root of 3, which is square root of 3. Square root of 3 times square root of 3 is square root of 9, which is a 3. So tangent theta is square root of 3 over 3. We go now to the cosecant theta. This is the inverse of the sine theta. If sine theta, or sine 30 degrees, is 1/2, cosecant theta is gonna be 2 over 1, or 2. Going to the secant, we have our inverse of the cosine theta. If cosine theta is square root of 3 over 2, our secant theta will be, or secant 30 degrees will be 2 over square root of 3. Since this is with square root of 3, we rationalize that one again. This is now with 2 square root of 3 over square root of 9, or simply a 3. So we have that. And then we go to the cotangent. This is the inverse of the tangent. If you got tangent 30 degrees is square root of 3 over 3, cotangent 30 degrees is equal to 3 over square root of 3. Again, we have a square root at the bottom part, so we do rationalize that one by multiplying it with square root of 3 over square root of 3. Our cotangent 30 now is 3 square root of 3 over 3, which is equal to a square root of 3, because our 3 there will be cancelled out. So let's now go for the 45 degrees. So we will be utilizing our 45 degrees triangle in here. And recalling the values of that one, we have this as 1, square root of 2 over 2, and square root of 2 over 2. So forgive me on that. Okay, let me just fix it. Okay, so utilizing the 45 degrees, 90 degrees triangle, we will be naming our values here. So we have our sine 45 degrees, that will be our opposite to our 45 degrees, which is the square root of 2 over 2. And the cosine 45 degrees, that's also the same value. And then for the tangent, 45 degrees. Since our x and y are the same in value, so that should be equal to 1. Next, we have the cosecant at 45 degrees. That is our inverse of the sine 40 degrees. So, which means we are going to flip that up. So, we have 2 over square root of 2, in which we rationalize that one again by multiplying that one with square root of 2 over square root of 2, in which our cosecant at 45 degrees, that will be equal to 2 square root of 2 over square root of 4, or simply a 2. And then we cancel that one out. So we are left with cosecant 45 degrees equal to a square root of 2. Then we go for the secant theta. So we have the same value for that one. We still have square root of 2. And then we go for the cotangent theta. So again, that's the inverse of the tangent, 45 degrees. So this is understood with 1 over 1. So we have 1 still here. And we now move to our 30, 60, 90 degrees triangle, because we will be utilizing that one for the 60 degrees angle. So we have to take note that the opposite our 60 degrees, that's square root of 3 over 2, while our opposite to 30 degrees, that will be 1/2. So you may refer to that one, or you can also refer to the 30 degrees values here, because 30 degrees plus 60 degrees, that's equal to a 90 degrees. Therefore, we are going to look at the cofunctions. When we say cofunctions, coming from the complementary word, which means once we say cofunction, they are complementary functions in which our angles, once we add up the angles, their angles, it will sum up to a 90 degrees. So the cofunctions here are the following. We have the sine theta and the cosine theta. They are cofunction if in the event that we have that as the angles are summing up to a 90 degrees. So which means if we've got sine 30 degrees, this will be equivalent to the value of cosine 60 degrees. If we have the sine 60 degrees, this will be equal to the cosine 30 degrees. And for tangent 30 degrees, we have that equivalent to the cotangent 30 degrees. 60 degrees. And vice versa. So if we have tangent 60 degrees, that means we have cotangent 30 degrees are with having the same value. Another cofunction here is the secant 30 degrees, that's equal to the cosecant 60 degrees, and secant 60 degrees, that's equal to the cosecant 30 degrees. So those are the cofunctions. So basically, if you know already the 30 degrees values, then that means to say once we have sine theta or sine 60 degrees, that will be equivalent to the cosine 30 degrees, which is square root of 3 over 2. Or if you are not then comfortable with the cofunction, you may refer to the triangle again. So once we say sine 60 degrees, we're referring to the opposite of 60 degrees, which is square root of 3 over 2. Then we have the cosine 60 degrees. We look at the sine 30 degrees, that's 1/2. And then we have our tangent 60 degrees. We look at the cotangent 30 degrees, that's square root of 3. And then the cosecant 60 degrees, we look at secant 30 degrees, which is 2 square root of 3 over 3. Then for the secant 60 degrees, we look at the cosecant 30 degrees, which is a 2. And then we are going to have cotangent 60 degrees. We look at the tangent 30 degrees, so which is square root of 3 over 3. Then we may now go to the quadrantal angles. For the quadrantal angles, all you have to do is to take note of the different coordinates of the unit circle in a Cartesian plane. So if this is 0 degrees or 360 degrees, this will be 90 degrees, and then we have 180 and 270 degrees. So take note, we are on the unit circle. That means to say, if we have a circle here, if we are to draw a circle here, this would simply mean that our radius is going to be equivalent to 1. So meaning from the origin going to this, we have that as 1. Then here we have that as 1 as well. And then going here, we have -1 for that. And our y here is -1. So we will now name our coordinates, starting off with the 90 degrees there. We have that as 0, 1. So 0, 1, our y value is 1. So we have that as sine 90 degrees is 1, while cosine 90 degrees is our x, which is a 0. And then tangent theta is y over x, or since sine theta is equal to y and cosine theta is x on a unit circle, which means that our tangent here will be also equal to our sine theta over cosine theta. So whatever is the value here, we just divide at 1. So 1 divided by 0, that is a no-no, which means that is an undefined. And then we have the cosecant 90 degrees, which is the inverse of the sine 90 degrees. This is understood with 1 over 1, so this is still a 1. And then we have the secant 90 degrees, the inverse of the cosine 90 degrees. Since this is 0, this is understood with 1 here. Once we do the inverse of that, that will become an undefined. Then going over to cotangent 90, that is our inverse of the tangent 90. So if this is undefined, we will have it as a 0 in here because basically that is 1 over 0. So once we do the inverse of 1 over 0, that's 0 over 1. That is a 0. So let's now go to 180 degrees. We have the coordinate for that one as -1, 0. So our x is -1, our y is 0. So sine 180 degrees is 0. Cosine 180 degrees is -1. And then the tangent 180 degrees, that's 0 over -1. That is a 0. Inverse of the sine, which is 1 over 0, that is an undefined. And then we have the inverse of the cosine. This is understood with 1, so literally we're having -1 here still. And then inverse of the tangent, since tangent is 0, this will be also undefined. Then we go over to 270, the coordinate of that one. So 270 degrees, the coordinate of that one is 0, -1. So our x is 0, our y is -1. So sine 270 degrees is -1. Our cosine 270 degrees is 0. Our tangent 270 degrees is -1 over 0. That's a no-no, that is undefined. And then we go over to the next one. This is the inverse of the sine. So we still have a -1 here. Next, the inverse of cosine, we have that as undefined because our cosine is 0 over 1. Inverse of that, that's 1 over 0, that's undefined. Inverse of the tangent, we have that as 0. Let's go over to 0 degrees or 360 degrees. So we have that as 1, 0. Our x is 1, our y is 0. So sine 360 degrees, that will be a 0. Cosine 360 degrees, that will be a 1. Tangent of 360 degrees, that is a 0. And then the inverse of your sine theta, that will be undefined. Then the inverse of the cosine is still a 1. Inverse of the tangent, we have tangent 0, so that should be an undefined. So that is how you are going to get the 6 trigonometric functions of the circular functions. Once again, this is your teacher Jenny saying, please do like, share, and subscribe to this video, and click on the notification bell for more videos.